Guys, welcome back to JP Concepts.
Today our topic is inspection of buried piping system. Now we are approaching to the last sessions of APA 570 code. Types and method of inspection for buried pipings. Above ground visual surveillance inspections. Indications of leaks may include a change in surface contour of the ground, discoloration of the soil, softening of the paving, asphalt, etc. Because you can have some indications in the ground. So based on that you can proceed the inspection. The second one, close interval potential survey. The close interval potential survey performed at ground level over the buried pipe and used to locate active corrosion points on the pipe surface. Since the potential will be measurably different from an adjacent area to the pipe, the location of the corrosion activity can be determined by this survey technique. The third one, pipe coating holiday survey. The pipe coating holiday survey can be used to locate coating defects on buried coated pipes, and it can be used on newly constructed pipe system to ensure that the coating is intact and is holiday free. More than it is used to calculate coating serviceability for buried piping that has been in service for an extended period of. It's a very common inspection method, holiday testing. It has to be done. From the survey data, the coating effectiveness and rate of deterioration can be determined very easily. Next point is soil resistivity. The corrosiveness of the soil can be determined by a measurement of soil resistivity. Lower intervals of resistivity are relatively more corrosive than higher levels, especially in areas where the pipe is exposed to significant changes in soil resistivity. Measurements of soil resistivity should be performed using 4-pin method, Werner 4-pin method, in accordance with ASTM G57. In cases of parallel pipes or in areas of intersecting pipelines, it may be necessary to use the single pin method to accurately measure the soil resistivity. In googling you can understand very easily what is 4-pin method, okay, and single pin method. The depth of the pipe shall be considered in selecting the method to be used and the location of the samples. Depth of the pipe is very important in this case. The testing and evaluation of results should be performed by personnel trained and experienced in soil resistivity testing. The cathodic protection monitoring. Cathodic protection monitoring should be done regularly to assure adequate levels of protection. Monitoring should include periodic measurements and analysis of pipe to soil potentials by personnel trained and experienced cathodic protection system operations. Reference codes are NACE Recommended Practice 0169 and Section 1 of API Recommended Practice 651 for guidance. Inspection methods. Normally, for buried piping, these three inspection methods are following. One is intelligent picking, IPS, it's called IPS. Second one is video cameras using video. And the last one is excavation method. Here we discuss about this frequency and extent of inspection of buried pipings in line with APA 570. Above grade visual surveillance. The owner or user should approximately 6-month interval survey the survey conditions on and adjust to each pipe path. Pipe to pipe soil potential. A close interval potential survey on cathodically protected line may be used to verify that the buried piping has a protective potential throughout the length. For poorly coated pipes where cathodic protection or in areas where leaks have occurred due to external corrosion, a pipe to soil potential survey may be conducted along the pipe route. A continuous potential profile or a close interval survey may be required to locate active corrosion cells. Pipe coating holiday survey. The frequency is usually based on indications that other forms of corrosion control are ineffective. Next, soil corrosivity survey. For piping buried in length greater than 100 feet and not cathodically protected, evaluations of soil corrosivity should be performed at 5 years intervals. This is as per APA 570. Sometimes the standards related to some clients, means some company will be different. Cathodic protection. If the piping is cathodically protected, the system should be monitored at intervals in accordance with the Section 10 of NAI's Recommended Practice 169 or Section 2 of APA Recommended Practice 651. External and internal inspection intervals of buried pipings. If internal corrosion of buried piping is expected as a result of inspection on the above ground portion of the line, inspection intervals and methods for the buried portion should be adjusted accordingly. The external condition of buried piping that is not cathodically protected should be determined by either pigging, which can be measured the wall thickness, or by excavating the area. Soil resistivity, if it is less than 2000, inspection interval should be 5. If it is 2000 to 10,000, it is 10 years, and if it is more than 10,000, you can go up to 15 years. Piping inspected periodically by excavation shall be inspected in length of 6 to 8 feet at one or more locations judged to be most susceptible to corrosion. Excavated piping should be inspected full circumference for type and extent of corrosion and the condition of the casing. If the piping is contained inside a casing pipe, the condition of the casing should be inspected to determine if water and or soil has entered the casing. The inspector shall verify the following things. Both ends of the casing extended beyond the ground line. The ends of the casing are sealed if the casing is not self-draining. The pressure carrying pipe is properly coated and wrapped. These are the things to be checked. Leak testing intervals. An alternative or supplement to inspection in leak testing with liquid at a pressure at least 10% greater than the maximum operating pressure at intervals 1/2 of the length of those shown in table for piping not cathodically protected, and at the same interval as shown in table 9.1 for cathodically protected piping. The leak test shall be maintained for a period of 8 hours, 4 hours after the initial pressurization. The pressure should be noted, and if necessary, the line repressurized to original test pressure and isolated from the pressure source. If during remainder of the test period the pressure decrease more than 5%, the piping should be visually inspected for leak. Buried piping also may be surveyed for integrity by using temperature corrected volumetric or pressure test methods. Other alternative leak test methods involving acoustic emission and the addition of tracer fluid to the pressurized line, etc. If the tracer is added to the service fluid, the owner or user shall confirm the suitability for process and product. Repairs to buried piping system. Repairs to coating, the first point. Any coating removed for inspection shall be renewed and inspected appropriately. For coating repairs, the inspector should be assured that the coating meets the following criteria. It has sufficient adhesion to the pipe. It is sufficiently ductile to resist the cracking. It is free of voids and gaps in the coating. It has sufficient strength to resist damage due to handling and soil stress. It can support any supplemental cathodic protection. The next point is clamp repairs. If piping leaks are clamped and reburied, the location of the clamp shall be logged in inspection record and may be surface marked, because the records of clamp should be properly maintained. All clamps shall be considered temporary and permanently repaired at the first nearest opportunity. Welded repairs. Welded repairs shall be made in accordance with the code. Records. Record system for buried piping should be maintained in accordance with this. This is already mentioned in the APA 570. You should have a thorough reading over this. Now we are entering to the last portion of the APA 570 code, that is appendixes. The first appendix A, this is related to inspector certification. I already explained the requirement of inspection certifications in my first volume of 570, so you can refer to that. And then the recertification, this is also I explained in 570, the first volume 1. So please go through that and prepare. Next, we can go to Appendix C. Don't get surprised why I'm not explaining about Appendix B. Appendix B is exempted from this exam, so no need to go through that. Then Appendix C, this examples of repairs. This appendix will give you the instructions while doing this repairs and all. This is related to GMAW and SMAW welding processes, and you have to go through this appendix. Just read it and try to familiar with this. That's it. The next one, small patch repair patches. Diameter of electrode shall not be exceed 5 by 30. These all are instructions related to your repair. Okay, just go through this. And the last appendix is Appendix D. This gives this MAWP calculations. This 2 examples for MAWP calculations. You should definitely study this, and I already explained this in the previous episode. That MAWP, this I captured this screenshot for that and I calculated there. So should be very much familiar with that. I am 100% sure there will be questions related to this. So by this one we completed this APA 570 code. I'm not saying that APA 570 certification. No, it's APA 570 code. All the other related codes we will discuss in the coming episode. So please stay tuned and please subscribe my YouTube channel JP Concepts for more updates. Thank you.